Welcome back. Here's our video tutorial for solving systems of equations by graphing. Solving a system of equations means taking two or more equations and finding the solution. That's a point x comma y. Or solutions. If there's many solutions, it'll be a line. Y equals mx plus b in slope-intercept form. That'll work for both equations if it exists. Let's try out three examples. Our first example, y equals 2x minus 2 and y equals negative x plus 1. We'll first draw our y and x axis and start with our first equation. Since it's in slope-intercept form, I plot the point 0, negative 2. This is my y-intercept. And my slope is 2. That's every 1 I go positive in the x, I go up 2 in my y. And I can graph that line. So I graph my first line, then I'll graph my second line. The y-intercept's at 0, 1. And my slope, because it's negative x, is negative 1 over 1. So every 1 you go positive in the x direction, you have to go down 1 in the y direction. And I can plot that line. So visually I can see that the two lines cross at 1, 0. That's my solution to this system of equations. And what that means is that if I plug in 1 for x, if I substitute 1 in for x, I should get 0 for y in both equations. Well, 2 times 1 is 2, and 2 minus 2 gives me 0. In my second equation, I would have negative 1 plus 1 equals 0. So I can check that off for both equations and show that it does indeed satisfy both equations. Our next example, y equals 4x minus 1 and y equals 4x plus 2. We'll graph our first equation, start at our y-intercept at negative 1. And our slope is 4 over 1, so every 1 I go positive in the x, I go up 4 in the y. And I graph that line. Our next one starts at 0, 2. And every 1 I go positive in the x, I go up 4 in the y. Now, because these have the same slope, they're always going to be the same distance from each other. These are two parallel lines. In this case, we have no solution. If they have the same slope but different y-intercepts, you can say that there's no solution, or you say that the lines don't cross. But our answer is no solution. Our third example, 4x plus 2y equals 4, and we'll also graph y equals negative 2x plus 2. If I have something in standard form, I look for my intercepts. I'm going to start off with my x-intercept. That's if y equals 0, so I can remove this term and say 4 times what equals 4? Well, 4 times 1 equals 4. So no longer my x-axis, I go to 1. And then for my y-axis, I can remove the x term here and say 2 times what gives me 4? Well, 2 times 2 gives me 4, so I can go up to positive 2 on my y and graph that line. Now my second equation is in slope-intercept form. I'm going to start at plus 2 on my y-intercept and follow the slope of negative 2 in my y and positive 1 in the x. And what I notice when I graph this, I get the same line. And in fact, if I convert this to slope-intercept form, they do end up becoming the same equation. So in that case, you can say there's infinite solutions, but we can say that they're the same line, and all pairs of numbers that satisfy this equation, that have this relationship, satisfy both these equations. So there are, in fact, infinite solutions. There will be more examples to come, but this is the general idea for this. Please be kind to yourself, be kind to others. I hope you have a great day.